Hi, my name is Brianna Mendenhall, and I will be presenting the Multi-Mirror Telescope. So, what is the Multi-Mirror Telescope? This telescope was originally built in 1979. This telescope is one of the world's largest astronomical telescopes. The original multi-mirror telescope had 6 honeycomb mirrors, each with a diameter of 1.8 meters, which is the image you see at the top. However, the telescope went under construction in 1998, and a team from University of Arizona replaced the 6 mirrors with a single 6.5 meter mirror, which is then the second photo that you see on the bottom. Due to the mirrors and the telescope, it is a reflecting telescope. This telescope can observe visible and infrared wavelengths of light. This telescope is located on the summit of Mount Hopkins in southeastern Arizona. And this telescope is operated by the University of Arizona and the Smithsonian Institution. So what is this telescope made up of? This telescope uses an adaptive optics system. And this telescope uses a total of 7 spectrographs, and I'm going to briefly describe only 6 of them, those including the red channel, the blue channel, the hectospect, the binospect, and the MMIRS. So the first one being the red channel spectrograph. This covers the red part of the spectrum. It is also used for various types of observations, including studies of galaxies, nebulas, and stars. The blue channel spectrograph covers the blue part of the spectrum and is often used for observing objects such as galaxies, quasars, and stars. The next one being the hectospect. This is a multi-object spectrograph that allows astronomers to obtain spectra for hundreds of objects all at the same time. The next one is the one that I find most interesting. This is the binospect, and this is a dual beam spectrograph that allows for simultaneous observations of 2 separate regions of the sky. The last one being MMIRS. This is known as the multi-mirror imaging spectrograph. This is a near-infrared spectrograph and imager that covers a broad range of wavelengths. This telescope uses both a color wheel and filters for the blue and red channel. There are just 2 fun facts that kind of stood out to me while I was researching this telescope. The first one being that this telescope is in a building because of the walls and the roof around the telescope need to be rolled back. As you can see in this image right here, it's in a building. This just allows it to cool down very quickly, and it improves the observations that are made. The MMT, known as the Multi-Mirror Telescope, was one of the first telescopes to utilize the concept of multi-mirrors working in a singular optical system. I'm so sorry. That fact is going back to the original telescope when it did have the multi-mirrors. Obviously, this photo is of the newer one that was under construction and was replaced with just that one mirror. So I'm going to go ahead and describe 3 of many discoveries that have been made by the multi-mirror telescope. The first one being the 2 teams of astronomers discovered a massive black hole. This was the first ever found in the galactic halo, thousands of light years above the Milky Way galactic plane. They used the red channel spectrograph that we just described previously, and this was discovered in the newer version of the telescope, the 6.5 meter mirror. This was discovered February 25th of 2015. The black hole that they discovered was at least 6 times as massive than our sun, and this was recorded as approximately 6,000 light years away. The second discovery was found on November 21st of 2007. astronomers discovered stars with carbon atmospheres. Arizona Steward Observatory astronomer Patrick Dufour stated, "We possibly have a window on what used to be the star's nuclear furnace and are seeing the ashes of the nuclear reaction that once took place." The stars that were discovered, among with 10,000 new white dwarf stars found in the Sloan Digital Sky Survey, which is incredible. Also stated in the article, astronomers currently believe this star somehow violently expelled all its hydrogen and all but a very small trace of its helium, leaving an essential bare stellar nucleus with a surface of 50% carbon and 50% oxygen. Now, the last discovery that I'll kind of explain, this is our most recent major collision with our galaxy. This photo is a small Magellantic cloud nearby dwarf galaxy that is merging with the Milky Way. The evidence gathered from this observation was convincing enough and can prove that a single dwarf galaxy merged with the Milky Way about 8 to 10 billion years ago, known as GSE. They also concluded that roughly 50% of Milky Way's current stellar halo and about 20% of its dark matter halo descended from it. So yeah, that is a multi-mirror telescope, and thank you for watching. And here is my works cited.